This is the part 2 video for 11.3. We did surface area pyramid. Now we're going to do surface area of cones, which is just going to be a slightly different formula based on what a cone actually is. So a couple of words to fill in the blank here. So a cone has one base that is a circle, and then it just has a vertex that's up top somewhere, all right? And then we have this weird shape, this triangular shape going around the outside of it. So the base of a cone is always a circle. In a right cone, the altitude, just like the other one we just talked about with pyramid, has an inside height and outside height. So H is like that altitude or that inside height, again, the height that we will not want, just like the last video. And that's just going from the center to the very, very top. The vertex is the highest point. And the height, again, like we said, is just the length of the altitude. The slant height, again, that cursive L, is that outside height, which we're going to need to figure out how big that lateral area is. All right, so that's the distance from the vertex along the outside of the cone to the base. So the lateral area is going to be half the circumference times the slant height. So just like what we did in the first video, 1/2 PL, now it's 1/2 of the circumference times L. So the cone, the lateral area of the cone would look kind of like a snow cone wrapper. The surface area would be the actual circle added into that. So we have two formulas to write down here, the lateral area and then the surface area. So the lateral area, kind of like what we had just talked about with pyramid, 1/2 P times the slanted height, except for now the perimeter is a circumference since we have a circle. So this time then we have our 1/2 PL, but P is going to be the circumference. So it's either going to be 2 pi r or pi times diameter. We're going to use r since it's going to help us with the area anyways, times that slanted height. But what happens with that is our 1/2 and our 2 are just going to cancel. So the best formula for LA, this is the one that I would highlight, is pi times the radius times the slanted height. So it's the same formula we've been doing, it just simplifies quite a bit. The surface area then is going to be the same idea, LA plus B, all right, well, but we can simplify that one even. The LA we just said is pi RL. B, capital B, since the bottom of a cone is a circle, we know the formula for that is pi r squared. So that might be our best formula for surface area of a cone. So that's what we're going to try to follow, and then it's going to be a lot like our other videos where sometimes we have the height that we need, and sometimes we have to figure out that height. So trying this out here, what is the surface area of the cone in terms of pi? So they don't want us to put pi into the calculator again, kind of like before. So what we have then, if we want to think about it this way with our LA plus B, we can try to find LA first. All right, but LA is just going to be pi times the radius times the slant height. It's simplified all the way down to pi RL. So we do know R on the picture is 15. We do have the outside height, not the inside height. So we do have L. We have everything that we need to figure this out. So we can go pi times the radius of 15 times the lateral height of 25. And let's just leave that in terms of pi right now as 375 pi. That's our first number we needed. Capital B is going to be pi r squared. And this time, like we said, we know that r is 15. So if we square that, we're going to leave that as 225 pi. So to get our final answer in terms of pi, we know that the lateral area is 375 pi, and the area of the base is 225 pi, so I can add those together for a total of 600 pi. We're square centimeters for this one, so that would be our surface area of that cone. All right, the next one, same idea. The radius is given to you as 16. The slant height is given to you as 28. So they gave us R, and they gave us cursive L. So in other words, we have everything that we need. So again, you can think about it as LA plus B, or you can think about it as pi RL plus pi R squared, however you want to do it. But a lot of them ask for lateral area separately, so we can do that first. Okay, for lateral area, we know that R is 16, the radius, and we know that L is 28, that lateral height. So we can do pi times 16 times 28 and get 448 pi. That's the first number that we need to answer this problem. That's our LA. B is going to be pi R squared, where R is 16. So the square, so pi R squared, 16 squared, is going to give us 256 times pi. So we have LA and we have B, so we can add those up. 448 pi plus 256 pi. We're going to leave it in terms of pi again, so we can add the numbers together to get 704. Don't forget that pi is part of that answer, and this time we are in square meters. So that would be our final answer, our surface area. The other two, the last two here on this note section, we have the wrong height. So we're going to have to deal with that again the same way as the first video. All right, this one just wants LA, so we don't have to get the final answer, just the lateral area. So the lateral area of the cone is pi RL. So if we're going to check what they gave us and what they haven't given us yet. They gave us that 80 is all the way across, so we call that a diameter. So that means that the radius is going to be 40. So I'm going to put that right into our formula here. So we have pi times 40 times, and L is going to be what we need to find. They gave us that this is 45, but that would be an altitude which we call H. Which means, again, we're going to have a right triangle looking for that lateral area, and we can use Pythagorean theorem to get that, because we have 2 out of the 3 sides of a right triangle. So I know that 40 squared plus 45 squared will give me L squared. So as we go through and solve some of that, we're going to add those together and get 3,625. And if we take the square root of both sides there, then we end up with what L is. We're going to keep a few decimal places here just so we can stay accurate. That's about 60.208. So we needed that number so we could plug it in, 60.208. So it doesn't say how to round this one. Since we have some messy numbers, we'll just plug everything in. So first things first, we would have about 2,408.32 just from doing the 40 and the 60, but that's still times pi. So we're going to say that that's about 7,562.1, and we're in square millimeters this time. So if you don't have the correct height, if you have H instead of L, we use Pythagorean theorem to get that figured out. All right, this one asks for both LA and SA. So again, the surface area is LA plus B, but specifically for cones, that's pi RL plus pi R squared. All right, but we can find them separately since they do ask for LA as part of the answer. So LA is pi RL, which means we have to make sure we know what both of those are. The radius is going to be 2 since the diameter is 4. L is something we don't know. They gave us this 5, which is the height. What we need is L. So I know that this is 5. I know that we have a side of 2, so I can use Pythagorean theorem once again to find our slanted height, our cursive L. So I know that 2 squared plus 5 squared will give me L squared, and this time that's 4 plus 25, or 29, equal to L squared. So when I take the square root of both sides, I have L on one side, and the square root of 29 should be a little bit bigger than 5, about 5.385. So I needed this number to plug in for my slanted height over here. So back to pi RL, I have pi times 2 times 5.385. So my lateral area, I can get that final answer now in terms of pi as 10.77 pi. and that would be in square feet. For capital B then, I was already ready to do this. Pi times r squared, or pi times 2 squared, which is 4 pi square feet. So I can go to get my final answer. I know that LA was 10.77 pi. I know that pi r squared, or capital B, was 4 pi. So altogether, exactly, I have 14.77 pi. Again, doesn't tell us how to round, but if we wanted to go to the nearest tenth of a square foot, that's about 46.4. And then we could use that as our final answer. So cones are going to be very, very similar to pyramids, which we just talked about, but it's a little bit nicer since we always have the same capital B, pi r squared. So really the question is going to continue to be whether or not we have the right height, the outside height compared to that inside height. All right, so you guys are ready to try that worksheet. Go ahead and move on. Make sure you ask any questions if something doesn't make sense.